Okay, so now we want to find cosine of 2 pi over 3, knowing what we have here, okay? So cosine of 2 pi over 3, well, t value is 2 pi over 3, so we know that it's going to be right here, from there to there, 2 pi over 3. So that puts us in quadrant 2, okay? So we know that t given 2 pi over 3 gives us a reference number t bar equal to pi over 3. So we don't have to know what cosine of 2 pi over 3 is. We just need to know that t bar is pi over 3. Now t bar being pi over 3, that's a quadrant 2 value. So we know that this number is going to be negative. Why? Because in quadrant 2, cosine is always negative. So we know our answer is definitely going to be negative. We know this is going to be cosine of 2 pi over 3 is less than 0. It is negative. Okay? So let's calculate. What is cosine of 2 pi over 3? Well, cosine of 2 pi over 3 is going to equal negative, we know it's negative, cosine of whatever pi over 3 is. Well, we know what cosine of pi over 3 is. It's one of those ones that we've memorized. We know that equals 1/2. Cosine of pi over 3 is 1/2. Therefore, I have negative 1/2 as my answer. Okay? So, we use our reference, again, review. We put a t value, we know we're in quadrant 2. We know our reference number is pi over 3. We know it's going to be negative. Why is it going to be negative? We're in quadrant 2. Cosine is negative in quadrant 2. So, cosine of pi over 3, figure that out. That's 1/2. Put a negative out front. End of story. Okay, tangent of negative pi over 3. Well, where's negative pi over 3? Negative pi over 3 lies right there, right? That's negative pi over 3. So we are in quadrant 4. Okay, what do we know about quadrant 4? Quadrant 4, what's going on with tangent? Quadrant 4, tangent, oh, it's negative. We know tangent is negative. So we know tan of negative pi over 3 is less than 0. So we know it's less than 0. We know it's negative. So we know that tan of negative pi over 3, and by the way, what's the reference number here? What's the reference number? Well, it's going to be pi over 3, right? That shortest distance along the unit circle from the x-axis to the terminal point. Okay, that's a distance of pi over 3. So we'll have tangent of negative pi over 3 is the same thing as we know it's less than 0. Negative tangent of my reference value, my reference number, pi over 3. And we know that negative tangent pi over 3, we know that pi over 3 is one of our special numbers. We know that equals root 3. So we'll have here negative root 3. Okay, that's how we find cosine and tangent of things when they're not one of our special numbers in quadrant 1. That gives us special coordinates. And we're able to use our reference numbers along with the idea that we know whether or not they're positive or negative based on this table. Okay, so up here I've got all our definitions for sine through cotangent. Again, we assume x and y cannot be 0 in these cases. What I want to do is I want to write down some reciprocal relations that we have. Basically what you want to note is that sine of t equals y. Cosecant of t is 1 over y. Therefore, we can say sine of t is equal to 1 over cosecant t. Okay? Or vice versa, cosecant t equals 1 over sine of t. These are reciprocal relations. Now we can do the same things for cosine and secant and cosecant to cotangent. Or excuse me, tangent and cotangent and cosecant and secant. They're just reciprocals of each other. So we can, again, these kind of go together. So these kind of go together. We have cosine of t equals 1 over secant t, or the same thing, secant t equals 1 over cosine t. And then we also have tangent t equals 1 over cotangent t, and cotangent t equals 1 over tangent t. So those are our reciprocal relations. And we also have some even-odd properties of these functions. So what do I mean by even-odd? So if you remember from your Math 38A class, or remember us defining in class what it means to be an even function. So even and odd, recall, even happens and odd happens in certain situations. If I have f of x equals, say, f of negative x, then that means it's an even function. And if I have f of x equals negative f of negative x, then it's an odd function. Okay, so we have some even and odd properties based on those things and looking at sign. First of all, let me write them down. Sine of t, if I have sine of the t value, actually we'll do sine of negative t. Well, that equals negative sine of t. Okay? So what's that say? That says sine is an odd function. We also have cosecant a negative t equals negative cosecant t. Okay? And both of those are odd functions. We also have some other odd functions. Tangent and cotangent are also odd functions. So tangent of negative t equals negative tangent of t, and also cotangent of negative t equals negative cotangent t. So all of these are odd functions. We also have some that are even. So we know sine, cosecant, tangent, cotangent are all odd. What are the even ones? And secant of t equals secant of negative t. Okay? Okay, so that talks about the even and odd properties of our trigonometric functions. Okay, what I want to do now is I want to talk about the fundamental identities of trigonometric functions. So fundamental identities. These must be memorized. Get some flashcards. Whatever you got to do, get a flashcard, take a picture of it, memorize it, write it on your mirror when you're brushing your teeth. You have to know these fundamental identities. Okay? Absolutely crucial. The first one is you got to know the reciprocal ones. We've already talked about the reciprocal ones. I'm going to rewrite them a little bit, including changing a couple ones. So, what do we know? We know cosecant of t is 1 over sine t. We know that secant t is 1 over cosine t. And we also know that cotangent t is equal to 1 over tangent t. Those are the ones that we've already established. There's also a couple others that we need to know. We need to know that tangent of t is equal to sine of t over cosine of t. Why is that true? Sine of t is y. Cosine of t is x. Tan of t is y over x. Y is sine, x is cosine, sine over cosine. Okay? So we have that one as well. We also have one other. We have cotangent t equals cosine t over sine t. Cotangent t, x over y. X over y, cosine over sine. Should kind of make sense. Now, as you remember, we know that x squared plus y squared equals 1. We know what x is. We know what y is. Therefore, we can establish that. These are called the Pythagorean identities. X squared plus y squared equals 1. X squared plus y squared would be sine squared t. We like to put the square there so as not to confuse with this, making it look like t squared. We don't write that. We put the square in between the n and the t. So sine squared t plus cosine squared t, x squared plus y squared equals 1. That's a Pythagorean identity. This is very important to know. Okay. So if I divide this guy by cosine squared, I get tangent squared of t. If I divide this guy by cosine squared, I get 1. And if I divide this guy by cosine squared, I get secant squared. So this is a new identity for us as well. Tan squared plus 1 equals secant squared. Okay. Now we can do the same thing, but instead of dividing by cosine squared in each one, we can divide each one of these by sine squared. If I divide this by sine squared, I get 1. If I divide this by sine squared, I get cosine squared over sine squared, cosine squared over sine squared, so x squared over y squared. I get this situation, which is cotangent squared. Okay. Again, I'm dividing by sine squared, so you're dividing by y squared. 1 over y squared is cosecant squared. Okay, so I have an example here. We want to find all values of the remaining trig functions if cosine of t equals 3/5 and t lies in quadrant 4. So quadrant 4, you might recall, all students take calculus, so cosine is the one that is positive in that situation. Okay, so that's cosine and secant are the positive ones. Everyone else is negative. So what we have here is we have cosine of t equals 3/5. So we want to find what the value of all the other trig functions. So sine of t and tangent of t and cosecant of t and secant of t and cotangent of t. And we have to find the values of all these guys. All right, so we know we're in quadrant 4. So we know that if we have all students take calculus, we know that cosine is greater than 0. Cosine of the value is greater than 0 in this case. All the rest are negative except for secant. Cosine and secant are positive in there. Okay, so how can we use it? What can we do to find this out? Well, what we can do is we can use one of our identities. We know that sine squared of t plus cosine squared of t equals 1. Now we know the value of cosine t, so we can square that here. So we'll get sine squared of t plus 3/5 squared equals 1, or sine squared of t equals 9, or plus 9 25ths equals 1. Subtract it over. So subtract it over, and I get 16 25ths. Square root both sides, and I get sine of t equals plus or minus 4/5. Now, you tell me which one is it. If cosine and secant are the ones that are positive in here, which one does this have to be? Sine of t. We're in quadrant 4 here. Sine of t has to be what? Negative. Sine of t has to be negative because the only ones in quadrant 4 that are positive are cosine and secant. So if sine of t is negative, then it has to be negative 4/5. So we'll put that in here, negative 4/5. And once we get this one, all the rest of them kind of just play out. Tangent of t is the quotient of sine of t divided by cosine of t. So we'll have negative 4/5 divided by 3/5. So that'll equal what? Negative 4/3. Cosecant of t is just a reciprocal of sine of t. So it'll equal negative 5/4. Secant t is just a reciprocal of this guy, and we'll get 5/3. And cotangent t is just a reciprocal, and we'll get negative 3/4. Okay, so this is finding all the values of the remaining trig functions if we know the value of cosine of some value t, and we know that t gives us a terminal point that lies in quadrant 4.